Hi, my name is Wendell, and I'm here to present my final project for the CS230 Deep Learning class at Stanford. For a final project, I chose to work on human action recognition with still images and videos. So since we're short on time, I'll just go through it quickly. So for the data set, for image action recognition, I used the Stanford 40 action data set, which is a collection of 40 images of 40 different action categories with about 180 to 300 different images per category. And for the video action recognition, I used the Kinetics 600 dataset, which is a huge collection of 600 action categories with at least 600 video clips per category. For models, for image action recognition, I use a number of models that are pre-trained on ImageNet and then fine-tuned using the Stanford 40 action dataset. And I also implement a paper that used a two-branch model where the top branch is a human localization branch which predicts a human mask, and the bottom branch is the usual action classification. And in this case, we have a 40-way softmax. For video action recognition, I used a 2D CNN that I trained from the image action portion. And then I trained a shallow 3D CNN and a deep 3D CNN using the Kinetics 600 dataset. So the challenging part of this project is, for the most part, trying to train the shallow and deep 3D CNNs using a Kinetics 600 dataset. So it's a huge dataset with 350,000 training videos and 27,000 videos. When uncompressed, it took up 4 terabytes of disk space, and I had to use multiprocessing in order to increase the throughput of the data pipeline, and also make use of 16-bit computations to increase the batch size by about a factor of 2 in order to reduce the training time from each epoch to eventually down to about 3 hours per training epoch. And so for the results, for image results, here on the left you see there's a number of different models or architectures I tested on. I tried it for most of the models. I tried both 224 by 224 input images as well as 500 by 500 images. And the ResNet 50 model performed the worst and amounted to pretty much random guessing. As you can see in the confusion matrix here, it just pretty much guessed everything. For everything that was not in the training set, it just picked one category. And for the Inception ResNet V2, it performed the best and gave me a validation accuracy of 84.1%. And the confusion matrix here looks a lot better. And down here, you can see the class activation maps for one of the models. For videos, actually surprisingly, the 2D CNN gave me the best accuracy at least for a 15 category subset at 59%. The shallow 3D CNN and the ResNet 3D CNN was at 42.5% and 41.1%. So this one was like a common subset, 15 classes that were common between both the Stanford action set and the Kinetics 600 dataset. For the 27 class and the 600 class, the numbers were actually lower. And we only trained it on the shallow 3D CNN, and we only tested this on the shallow 3D CNN and the deep 3D CNN. So the reason why this is lower is actually not because that it should actually be higher because we have more data. Unfortunately, the training time and computational resources were expensive, so it made it difficult. So that's pretty much all the time I have left. So thank you for watching.